Hi everyone, I'm Nico. This is my DIY atmosphere model. There's the Earth, the Troposphere, the Stratosphere, Mesosphere, Thermosphere, and Exosphere. There's 5 layers of the atmosphere in total, and we'll start with the Troposphere. It's the first layer of the atmosphere. It's the lowest, obviously, since it has an altitude of 0 to 14.5 kilometers. It has an air pressure of 1000 to 200 millibars, and it has temperature of 15 degrees Celsius down to negative 60 degrees Celsius. This is because the troposphere has 99.9% of the atmosphere's gases, so definitely why the air pressure is that thick. And as for the temperature, it went down because the troposphere gains most of its heat through the Earth's surface. That's definitely why the temperatures go down. Next, we have the stratosphere. The altitude is 14.6 to 50 kilometers. This is why this is the second lowest atmosphere layer. It has an air pressure of 200 to 1 millibars. Again, because 99.9% of the gases of the atmosphere are in the troposphere, so the gases in the stratosphere are starting to thin out. There's not as much gas molecules. And the temperature is increased from negative 60 degrees Celsius to negative 15 degrees Celsius. This is because the stratosphere contains ozones. It houses 90% of the ozone layer, which absorbs the UV radiation from the sunlight. Next, we have the mesosphere. This is either the third lowest or highest layer of the atmosphere because the mesosphere is in the middle, right? It has an altitude of 51 to 85 kilometers and an air pressure of 0.09. Let me focus that. 0.99, to 0.01 millibars because again, gases start to thin out up to the highest layer of the atmosphere, which is the exosphere. So air pressure is just going to go down at this point until it's very little because there's less gas molecules, so gases thin out. All right, and the temperature here is decreasing like the troposphere from negative 15 degrees Celsius to a whopping negative 120 degrees Celsius. This is because the mesosphere again has really thin gases. It doesn't have as much gas molecules, gas elements. Therefore, the only source of heat is from the stratosphere, which again, the stratosphere absorbs UV radiation, which is why the stratosphere increases in temperature. So mesosphere doesn't have any significant source of heat, so it just only takes heat from the stratosphere. That's why the temperature decreases, right? Now we move on to the second highest layer, which is the thermosphere. It has an altitude of 86 to 600 kilometers, an air pressure of 0.009 to 0.005 millibars. Again, because gases thin out, and the temperature significantly increases from negative 120 degrees Celsius to 2000 degrees Celsius. Similar to the stratosphere, this is because the thermosphere gains its heat from absorbing UV radiation from sunlight because it's closer to the sunlight. Pretty much that's why its temperature can go directly up to 2000 degrees Celsius, along with lower gas molecules, lower amount of gas molecules and thinner gases, right? And the exosphere, it's the highest layer of the atmosphere. Its altitude is 601 up to 10,000 kilometers above ground. its air pressure, it's below 0.005 millibars. There's no current research that states the limit of the lowest air pressure, but that's all we know. It's below 0.005 millibars. And the temperature, surprisingly here, is going down as well from 2000 degrees Celsius to 1500 degrees Celsius. This is pretty much because the exosphere has more gas molecules. Surprisingly, it has more gas molecules than the thermosphere. So that's why it has lower temperature of, it goes down by 500 degrees Celsius. And yeah, this is pretty much the result. Again, the Earth, troposphere, stratosphere, mesosphere, thermosphere, and exosphere. That's pretty much the DIY atmosphere model. It helped me to understand the causes and effects and the relationship of between the altitude and air pressure and temperature of each of the 5 layers of the atmosphere. Thank you for watching this video. Hope it's helpful and hope it can help you create a DIY model of the atmosphere along with my atmosphere model creation process video. Once again, thank you for watching.